section, we will keep the recording as well. So please beware about the recording. For today, it's the May time of our Cloud Security Alliance knowledge sharing sections. It's a great time that even I think right now during the COVID-19 situation, it's less severe already. So more of our events we can arrange, but still, I think it's a good time that for our knowledge sharing section that we can arrange during the lunchtime, so we can have more participants that they can join through the network as well. So this is a series that is about the secret in the cloud environment. I think some of you may be aware of the company, that's HashiCorp, but if you're not really aware, then I think if I name two of their products, then you probably should have heard about that. One definitely is the Terraform. So the second one is the HashiCorp, HashiWatt. So I think it's a good time that we switch from just learning about the infrastructure and also from the infrastructure-based security to some of the ways how we can secure and store the secrets. So in this event, we have invited speakers, and really thanks a lot as well. Thanks ACW Derek introduced the team to us here. So HashiCorp's teammates, the developer advocate. I try to pronounce the name Shohei. So am I correct in pronouncing the name? Or maybe it's a better time that I pass the time to you so you can have an introduction of yourself.
Yeah, it was close. My name is Shohei.
Shohei. Okay. So let you take over the platform.
Yeah, I can start now. So, by the way, can you see my screen?
Yes.
Okay, so it's on the screen for I can really see if my screen is on or not. So I wasn't sure. Like, okay, then I can start now. All right, hold on. Yep. So if I move slide, can you see this?
Yes.
Okay, sounds good. Right. So hi everyone. Thanks for inviting me. I'm happy to be here. So today in this webinar or a talk or session, whatever, I'm going to talk about this title, which you can see right here, managing secrets at scale for a secure cloud workflow. So before getting into this talk, I just wanted to be clear that my talk today is not something we HashiCorp, or at least myself, trying to sell a product. No, but rather discussing how we can do better when it comes to this secret management in general. So of course, I will be introducing some of our tools, but they are basically all open source. So, and that's just one way to do better things out of other available options out there today. So, with that in mind, again, my name is Shohei. I'm a senior developer advocate working at HashiCorp, and I'm currently based in Tokyo, Japan. And I actually joined HashiCorp back in January this year, so I'm still somewhat new to the company, to be honest, and I'm still catching up a lot, running a lot, and I'm at a very early stage of this long running card. So yeah, but I hope this my talk today wouldn't be that boring to you all. And although most of my activities are in Japanese, here's my Twitter handle. So if you're curious enough, please feel free to follow me on Twitter. So and say hi, so we can chat about, I mean, anything over there after this talk. Right. So the agenda is pretty compact, as you can see. So I will probably not spend a full hour for today's session, but one, that I'm actually not a good English speaker, to be honest, and two, if I speak at a normal speed, I think this talk will only take 20 to 30 minutes. So therefore, I'm going to speak a bit slow today, but please don't complain to me about that. I think
No
this will,
problem. It's a
yeah,
good speed.
yeah. So this will actually help my pronunciation so quite a bit. So I hope I'm making this talk easier for everyone. All right. Uh, so the first slide is just to give you a portfolio of HashiCorp and an overview of what HashiCorp is as a public company. And I know like not many people know about HashiCorp as a company until like we say, hey, HashiCorp is a company developing Terraform. And as soon as people hear that word, like Terraform, they're like, they usually like, oh, yeah, we know Terraform, and like we use Terraform for blah blah. So yeah, that's good. Terraform these days got pretty famous for many engineers, especially for those tackling this gigantic like DevOps field. And yeah, by the way, if you don't know about Terraform, Terraform is a tool for infrastructure as code, also known as IAC. But really, the thing I wanted to mention here in this slide is that HashiCorp is not just a company developing Terraform. We provide many other products, as you can see here. So I won't be talking about each product today, but at the core, we deliver cloud infrastructure automation in multiple layers. So in this diagram here, like we have tools from bottom to top, which refers from infrastructure to application layers. So like Terraform is for infrastructure as code, and Bolt for security, which is a tool I'm going to talk about today, and Console for networking, like service discovery, service mesh, and Nomado Waypoint for application delivery, so on and so forth. And what's really interesting about HashiCorp, I think, is surprisingly, all these tools you can see here are open source. So meaning you can start using them for free. And so like so far, our culture is a bit unique in a way that all our tools starting from this open source, and we keep maintaining these open source as well as some other non-open source versions. So there are things like enterprise versions, or we also have our own cloud-based offerings, and some of our tools are available in that like SaaS model. So yeah, with that, I hope you get a basic sense of who we are and what we do as a company. And next slide. So hopefully, this is a very obvious statement for all of us, and that's like we know this managing secret is like what to me. And if you say like managing secret is easy, that's amazing, and I would love to set up an hour interview with you and hear your thoughts on that and see what magic you use and what magic you have. But anyway, for most of us, or at least for myself, this this secret management is not an easy thing. It is indeed difficult and complicated and maybe chaotic, nightmare whatsoever. And just by seeing these recent few data breaches like happened in the past few months, I think it's very clear that this world we are living in today still doesn't seem to have figured out the best answer for that. I mean, just yet. And to be fair, there's some good progress going on in the industry, as you may know. So for things like passwordless solutions, like FIDO, WebAuthn, those new technologies. But we gotta remember that those those technology generally for consumers. I mean, for in the other words, those are human to service authentication, and that's a completely different segment that what we are what we're gonna be focusing on today in this talk. And generally speaking, human to service authentication is kind of getting robust and secured like these days, I would say. For example, like your organization should be using some sort of single sign-on solution to access all those different kinds of internal tools or services. So you don't have to remember, or you don't have to manage each service secret. And there should be there should also be like some sort of two-factor authentication on top of those single sign-on solution. So that's good. Sounds pretty decent. But again, this cannot be applied to application to or machine to service access authentication fraud at all. And this is the challenge we're facing right now. So what is a secret? I know this is a this is a kind of silly slide to include, given today's audiences are probably like security professionals. I'm actually not sure like the what the audiences are, but I'm just assuming. And but please just bear with me. I'm not a security professional at all. So let's just go through this quickly. So when we talk about secrets, when we say secrets, essentially those are anything, anything that gives us access to protected resources or protected information, or allows us to authenticate or authorize ourselves, right? So the most typical example is, of course, our great longtime friend called username and password. But we also have this many other forms of secrets, such as, in this case, IAM credentials that are used to access your crowd environments, or maybe SSH keys to get into your machines, TLS certificates and its private key, or just any other third-party API tokens that your system used to interact with those APIs. So we all know that there are so many secrets, and we must be dealing with these many types of secrets day to day. Even if you are not an engineer or a tech person at all. So, so we know what the secrets are, obviously. Then where do they live? Um, so let's say you have all these multi-cloud environments like AWS, Azure, and GCP, as well as some other cloud services used by your system. And now you have this many secrets issued by each service provider. And that may live in someone's computer. Like hopefully they are not post-it notes on their keyboards, monitors, but those secrets may be like sitting in your applications and or CI/CD pipeline, for instance. And so in a real world organization, and adapting such multi-cloud strategies, managing all these different secrets and also distributed to many places becomes a much harder problem to solve in many cases. So this is what we call secret sprawl. And it just means what it is originally. And secrets are sprawling all over the place, and that's secret sprawl. And a classic example would be a database password, like how to code it in the source code of your application, or maybe in plain text in some form of a configuration file on your file system on your server, or maybe in an internal wiki page. And my favorite one is always like share the Excel file protected by password. And I'm always joking about this, but it's not really a joke actually in some cases. I mean, even myself, some years ago, I once had a company selling this security software, and that is also known as a leading security company in the industry. And I was in an IT team that was managing all kinds of production networks, production servers, production storage. But the reality at the time was this exact like shared Excel file containing a bunch of static, long-lived secrets. So as your technology changes, your business, your organization grows, and you get more employees, services, and system to manage, then you will have more and more external integrations that your system will talk to. And these secrets will never stop increasing, unfortunately. So, so yeah, you can easily imagine that in many organizations, secrets are sprawled all over the infrastructure in different places. And, and then you also have this big problem of rotating secrets, which can be a nightmare in often scenarios. And also auditability is very critical for compliance or traceability, especially in a compromised situation. But it can also be quite tricky as well in the secret sprawl world and situation. So, so we just talked about what the secret sprawl is, and that we see like we have many challenges when it comes to secret management. So why don't we just take some like moment, take some time and ask ourselves to even answer these basic questions, right? So it's it's actually very difficult to answer, right? Just as we talk, we don't really know like, how many secrets exist or how many secrets are in use, and we don't even know what secrets are where exactly, and it's just all over the place, and we don't we don't yet know the reliable and universal, a consistent way of retrieving secrets securely from across all different entities. The importance of auditability for secrets is often gets missed and underestimated, and it only gets important once a big incident happened, and which is too late. And with static and long-lived secrets, the amount of effort in response to a compromise is just huge, and it's just time consuming. So we are pretty much in a jungle, really. And now, as a solution to those challenges we saw earlier, I'd like to introduce one of our many tools, and that's called HashiCorp Bolt. So, oops. So there's a commercial slide that's I'm not really going to mention, but some stats numbers and customers loggers who use both. Like, so you see we have many enterprise customers. Yeah, that's that. And so this is the Bolt approach. If you have used Bolt before, or even using HashiCorp Bolt in your organization right now, that's awesome, and thank you. If you don't know about HashiCorp Bolt at all, that's also perfectly fine. So HashiCorp Bolt is well, it means a lot. It provides a lot of things, a lot of functionalities, but at the core, it's designed to be a single source of trust in your secret management workflows. So there are similar tools available on the market, but those tools are often like barely specific to a certain cloud environment and barely limited feature set compared to our HashiCorp Bolt. So Bolt is barely cloud agnostic and also barely platform agnostic. And this is very important when choosing the right secret management solution that is flexible and scales to any platform. And that said, when we talk about secret flow and how to solve it, the first thing to do is centralization of your secrets. And with with a HashiCorp Vault, you can not only store your static secrets securely by encrypting them like a key value store, but you can also generate what's called dynamic secrets on demand by client requests. And I'll explain later what the dynamic secrets is. And Bolt then also provides fine-grained access control features that restricts what secrets you have access to on a needed-to-know basis. So this way, because now everything can be centralized in Bolt, we have more traceability as to when secrets were used and by who, just by looking those audit logs generated by Bolt. And another advantage is this identity-based securities because clients access Bolt in order to get secrets stored in Bolt or generated by Bolt. They will also need to authenticate themselves into Bolt first. And when doing that, since Bolt supports many external identity providers, clients can authenticate using their own identity, such as cloud IAM platforms, maybe Kubernetes, Active Directory, etc. And this is usually much more secure and scalable than traditional low trust security, such as an IP-based access control list that is hard to maintain and hard to scale. In the start point of data encryption, this is not something I'm going to talk about much today, but in short, you can use Bolt as an encryption as a service platform. So you can use Bolt to encrypt and decrypt your application data, but without storing those data in Bolt storage. So let's say if your website has to collect customers' like credit card numbers, and your application must store these numbers somewhere in your database, but in an encrypted format. So so you never store raw credit card numbers, of course, in your database. But then now you have to you have a generic problem of how to encrypt and how to decrypt those data in the most secure and consistent manner. Writing this subtle cryptographic logic in your application by yourself can be quite challenging. And it's 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 easy to make a like mistake that may or may not be a critical problem later on. So with HashiCorp Bolt, you can offload that logic to Bolt, and your application will just need to interact with Bolt using REST APIs to encrypt or decrypt your data. So that's the brief introduction of Bolt. And the next slide. Yep. So I think that was a bit too much for some of you. So let's just simplify that that the Bolt overview into these two main components of Bolt, and that is auth methods and secret engines. So an entity in this diagram, reft, can be a human, application, or a machine. And this amply makes a request to Bolt to authenticate or authorize itself. And by that time, it's going to use one of many auth methods that Bolt supports. And once that auth part is done, the Bolt will return a secret to the entity. Um, this can be either static or dynamic secret, returned by again one of many secret engines that Bolt supports. So yeah, as I mentioned, Bolt supports many auth methods, and there should be one in this list that fits your organization and or your system. It's worth noting that some of these methods are intended for human access. For example, like in this list, GitHub, Okta, LDAP, username, password. These auth methods are for human to service access. But remember that why you generally want to use Bolt is to provide a consistent interface for application and machines, not just humans. And those non-human entities are the main areas that's where Bolt really shines and find its most value. Okay, and what about secret engines? We talked about auth methods in the previous slide. So we have many secret engines as well, but what's important here is that, as I mentioned earlier, what makes Bolt so special about secret management is that it gives you the ability to generate these dynamic secrets on demand. And in fact, many secret engines in this list support this type of dynamic secrets. For instance, you can easily generate dynamic ephemeral public cloud secrets that are short-lived. And this is a great fit with your CI/CD pipeline that require access to those public cloud environments. So the generated secrets can be revoked right after the job is finished, or it will just expire once the configured TTL time to live has reached. And for those traditional static secrets, Bolt still can store them securely, but it's just a tiny piece of all the available secret engines that you can see. So more you adopt dynamic secrets, the more secure secret management you will benefit from. And the next slide. So the diagram in this the diagram in the last few slides are very oversimplified, just because I wanted to give you a very high level concepts. But there's another very important concept to understand, and that is access token. And when an entity or a client, in this case, authenticates into Bolt, the very first thing they will get from Bolt upon successful OS is not a secret itself, actually, but instead they will get an access token. And by providing this issued access token to Bolt, now they can access and get the secrets they want from Bolt. So this is how Bolt authentication works. But to understand this notion of the access token more clearly, let's just use this example of a hotel reception. So let's say you arrived at the hotel reception, and now the receptionist asks you to provide your identity, such as your ID, and you provide your identity to the receptionist. Then they need to validate you and check who you are and make sure your identity matches. So in the Bolt world, this process can be translated into the identity provider flow in this diagram. So Bolt will talk to the right identity provider depending on the provided identity type from the client. And once the client's identity is verified, then Bolt will generate an access token. This is exactly like a hotel room key you get from the receptionist. So just like a room key, the issued access token also has a TTL, time to live, and can be revoked at any time if necessary. So once it's expired or revoked, you would not be able to access data in Bolt anymore. And this access token also has policies attached. So this means you can only access secrets that are allowed by those policies. The same thing applies to the hotel room key, right? It has a policy attached to it, so you cannot enter someone's room or the hotel facilities unless it's explicitly allowed by the policy, right? So I hope this hotel reception example made sense to you. All right, so to the next slide. Then let's think about more like real world problems in real world use cases. And this time, I'm going to use this secret management in CI/CD pipeline example. But first of all, today in this example, I'll be specifically using GitHub Actions as an example. But all the concept I'm going to talk about can be applied to other similar CI/CD tools such as GitLab, CircleCI, etc. So, assuming that you build a workflow that does these pretty basic job steps like test, build, push, and deploy. So for the first two stages, you usually don't require any secrets in these two stages, right? In the test job, you just set up your environment and do some local testing, and then in the build job, you build something locally from your local source code. So secrets are not required in these stages. But after that, now say we want to push this artifact to somewhere outside of GitHub Actions, which means you need to authenticate with that system, and there must be a secret for that. The same thing with the deploy job. We want to deploy to a public cloud environment, which requires another secret. So secret, what I mean by secret here is this can be like cloud IAM credentials, API tokens, or certificates, whatever. But as you can probably see, this this is a fundamental problem of any CI/CD pipeline. So the most most traditional way of managing secrets, for example, in GitHub Actions, is to use GitHub Secrets features. This allow us to store any secrets in the GitHub infrastructure with the data encrypted. So you add and you define your secrets and your repository or under your organization level, then you can easily reference and consume those secrets from your actions workflow. Like in this example, this right. Um, this is of course pretty handy and easy to get started. But remember what we just discussed earlier with regards to secret Sprawl. So this is exactly contributing towards secret Sprawl. And in fact, like many organizations find it very difficult to manage this kind of like GitHub secrets ecosystem at scale. And again, the same problem exists in other CI/CD tools as well. Like if you're familiar with Circle CI, they also have a similar functionality called environment variables, where you can store secrets as well. So for example, like in this case, for GitHub Actions, what are the available options in terms of secret management? And the first one we just talked is the GitHub Secrets, and as you know, that's probably not our first choice if possible. And the second one is the GitHub Actions OIDC support. OIDC stands for OpenID Connect, which was launched last year. And this seems pretty promising. And by adapting this OIDC model, we could get rid of any uh, we could get rid of use of the GitHub secrets entirely. The last one is self-hosted lambdas. This used to be a popular solution before the GitHub Actions OIDC launch, because this also allows you to utilize your like cloud IAM credentials supplied by your instance metadata. For instance, like you could use your EC2 IAM role from the self-hosted runner that achieves their credential models. But operating this self-hosted runner infrastructure can also be a silly as pain. So unless your actions really needs some sort of private network reachability with your private resources, this wouldn't be the first choice as well. So by that, um, then why not we just use Bolt for this particular example? As I mentioned earlier, Bolt, HashiCorp Bolt does support JWT and JOT and OIDC auth methods. So this means we can define a so-called trust relationship between the GitHub Actions OIDC provider and our Bolt instance. In other words, we don't need to store any secrets in GitHub or Bolt to set up this trust relationship. So all we need is to create a few settings and policies in Bolt, such as it's just a filter rule defining what OIDC claims to trust. For example, you want to trust a JWT token that is issued and sent by a certain repository only, or you could also filter by like repository owners or the workflow name that trigger the job, so on and so forth. And by obtaining the access token from the Bolt, which I explained earlier, now your GitHub Actions can fetch static secrets stored in Bolt, or you can even generate dynamic secrets to access those public cloud environments. And you can see there are so many use cases you can think of with this flexible model using OIDC. And maybe like someone who is already familiar with GitHub OIDC, GitHub Actions OIDC support, they may ask something like, why do we need Bolt in the first place? Like, isn't possible to just set up OIDC trust with those public cloud vendors directly, right? Just between GitHub Actions OIDC and say AWS, for instance. What's the benefit of having Bolt in between here? Well, that's half true and half wrong, I'd say. So yes, you can set up OIDC trust with say like AWS, GCP, and Azure directly, but then going back to our earlier discussions and challenges around secret sprawl, then you see that this auditability is still somewhat ambiguous if those logs are all over the place. And also, what if your jobs still require static secrets that cannot be converted to dynamic secrets in any way? Do you still leave them to, for example, GitHub secrets? Then again, the same problem, secret sprawl, is still there, and you might be, just adding unnecessary complexities. So really, the key here is to centralize all workflows around secret management, and that's what Bolt does in this example. Okay. Right. So it looks like it's time to demo. So I just wanted to show some very easy examples. So in this diagram, we set up a trust relationship between GitHub Actions and Bolt, and I already set up that environment. And we also have, maybe this is a bit small. We also have a HashiCorp Bolt action, our official GitHub Actions. So you can use this official action to authenticate with Bolt using OIDC. It's pretty easy and it's pretty handy. And for example, this is the simple OIDC workflow that I just prepared earlier. In this case, what I'm doing is I'm just using this official HashiCorp Bolt actions here, and I'm just providing these parameters. And there's no secrets in this workflow. These are just parameters, and they're not sensitive at all. And so this is a URL to my Bolt instance, and others are just some Bolt specific parameters you need to specify. In the last line, this is the important setting, which is the secrets. Here I can specify which secrets that I want to get from Bolt. So I want this secret stored in this path a demo secret, GitHub HashiCorp demo, and the data of fastly key. And I get this secret from Bolt, then I also want to export that secret to this environment variable called fastly token, so that this environment variable can be used in the subsequent steps. So in the next step, you can see here, you can see I am just randomly sending an API request, and that is fastly API. So I can using this secret that is derived from Bolt. And then finally, we can revoke this token by ourselves using REST APIs. So if we just run this workflow real quick. So in this GitHub Action example, I am only using the static secrets. So it's completed. It's completed and see. Yep. So get secrets, and in this tab, this fastly token is retrieved from Bolt on demand, and we can send the API request with that token. And you can see it's getting 200, which means the token is valid. Another a bit more advanced use case is, for example, we also have a Circle CI custom OLB. This is something I published recently. OLB HashiCorp Bolt CLI. This allows you to install HashiCorp Bolt binary in your job environment, and we have some helper commands to authenticate with Bolt using OIDC, because Circle CI also recently supported OIDC. So we can use the exact same technique. And this is the Circle CI example. It's a bit long because I'm doing more advanced stuff. So the first thing I'm using my custom lobby and install HashiCorp Bolt CLI and authenticate with Bolt, and I'm just providing the parameters the same as GitHub Actions example. And then we get static secrets from Bolt using this Bolt CLI command directly. So in this case, we are fetching this Circle CI demo secrets in key 1, key 2 from remote Bolt. And for debugging purpose, we just echo those secrets output. And then in the next step, we are generating dynamic secrets. This time it's a AWS STS token that is short-lived. So we specify TTL is 30 minutes, and we generate this dynamic AWS STS token using the Bolt CLI. And we pass the result, and we set those AWS credentials to environment variable, so that the next step we can use AWS command just fine, because the AWS command automatically detect those environment variables. So if you look at the Bolt has a UI, by the way. So this case, I'm at the Circle CI demo secrets. So key 1, key 2, the values are foo and bar, you can see. And if I run this Circle CI job, what you can see here is like this. So authenticate with Bolt and get static secrets and show static secrets. And you can see here the secret key 1 is foo, secret key 2 is bar. These are all fetched from the remote Bolt. I'm not defining any static secret in Circle CI environment variable or something. This is all done by on demand. And then we generate dynamic secrets in this job, and we set the AWS token. Then we just try to fetch some random text file from the S3 bucket, and you can see the content of this secret.txt file. And hello Circle CI meet arm. And then we can revoke the Bolt token as well. And now you see this success message, revoke token. So what happens if we try to again generate dynamic AWS token using this revoked Bolt access token? It will fail, and you can see the next attempt to generate AWS token is got a 403 errors, permission denied, because we just revoked this Bolt token, like the hotel car key. So you cannot use the same token anymore. So yeah, these are the demo. I wanted to go through quickly and see the Rust job. Yeah, job is finished. Okay. And so this is the last slide. This one is from our marketing team at HashiCorp. It looks like we are giving 50 Hong Kong dollar to 10 lucky participants who are willing to fill up this survey form. So please scan this QR code and go to the link. I think this hobby should be pretty short to complete. So yeah, feel free to scan this QR code now and complete this hobby. And my talk is done. Thank you.
Thanks. Really thanks, Sohi, for your presentation. I think yes, this time and also the coverage is rather good. It's very interesting. Um, so I think it's other than the form which Nora just sent out. Uh, Please, if you want to participate in this lucky draw, please, or actually it should not be lucky draw. Actually, it's a survey form. Maybe Nora, do you want to say something about it?
呢個係如果你哋想fill up 都係可以 fill up 嘅，跟住之後就有一個 lucky draw 啦。如果係咁有一個50蚊嘅Starbucks voucher 啦，一個少少嘅嘢啦。咁呢個係即係冇話一定要規定要 fill up 嘅，即係你哋即係如果你哋想 fill up 就可以 fill up 啦。咁如果你哋想識多啲關於即係對 HashiCorp 有interest 啊，想知道啲 HashiCorp 咧嘅產品嘅資料，亦都可以喺翻我喺個 chat 嗰度啦 learn.hashcorp.com 嗰度，咁嗰度其實有好多好詳細嘅 HashiCorp 嘅資料，你哋可以去睇翻咯。係啊，咁成千產品都有噶啦，我哋有8個產品，全部嗰啲 information 都有齊噶啦。係啊。
Good. Okay, thanks. Shohei, can you see the chat? Can you see the chat? I think other than my question, some of our participants may also want to ask something more about the demonstration and also about the HashiWorld. So maybe I try to type in the question here, but I will try to recap what I just want to say, so it may be easier for you to also refer to the word as well. So I think the first thing which I usually come into mind is that, to my understanding, HashiWorld can actually be implemented both in the cloud and also on premises as well. We encountered cases that one of our customers actually implemented HashiWorld in on premises, and what as a security consultant which we encountered is that the usually we will tell customer try to keep the variables, values, things into the vault because that should be able to encrypt and protect the data. But as we suggest them to put the variables and values into the vault, how can we validate? Only the validated entity would be able to access to the value in the vault. How can we ensure that? That's the first part of the question. And then as you mentioned as well, entity actually can be programs, especially its automated way. So if it is an automated kind of program, then the program, if we say they need to put in some of the secret inside, then there's another secret. So how can we ensure a program, an automated program, can actually participate in this validation and able to confirm that it's just that particular program can communicate, not the others. Some of the other programs that cannot get the value from the vault.
Yeah, so for the second question, so Bolt support like many external identity providers. So when, let's say, the entity is a program or applications, you don't necessarily be using some sort of secrets to authenticate with Bolt. You can use some of the identity-based authentication method. For example, like if the application is running on the existing instance, then you can authenticate with Bolt using IAM role. So that's not a secret. Or maybe if it's running on Kubernetes, both can also authenticate using Kubernetes using the service accounts. So these are different kinds of identity-based authentication. There's a way to avoid having the like this static secret just to authenticate with Sprawl, and like the example we just saw in the CI/CD pipelines, if you use OIDC, there's no secrets. We just define trust relationship, so no secrets going on in between in those parties. So it's pretty much secure, and you can define the like rules depending on like you can only accept the OIDC request from a certain repository or certain user. Yeah, there's a way for that, and I'm not sure if that answers your question, but yeah.
Yes, yes. Any other participants have any questions that you want to ask? It's a good chance that we can get some first-hand answers from our speakers.
This is actually my very first English public speaking, so I'm pretty much nervous.
No, you're doing very well. Frankly speaking, I think some of our participants here actually have attended conferences in other places, especially sometimes in other conference. We met speakers from Japan. You already speaking very well already. Yeah.
Thank you.
Okay. Really no questions. That's mean Shohei is speaking covered very well in the topics. So maybe I think especially if we have questions, I think we can contact Shohei further, and also it would be good that we can have some of the further sharing and discussion. Maybe next time we ask you to cover one of the other topics that is about the Terraform. So yeah, that is also definitely one of the topics which many of our participants would like to know as well.
Right.
So really no questions. Then we give thanks to Shohei. Thanks a lot for your coverage, and for our events, just like to highlight two of the upcoming one. Firstly, next month actually is just less than 14 days. I think 15 days time. We will have another knowledge sharing events that's by Checkmarks. So they will talk about some of the their open source solutions, and so we will have our. You can visit our website, and then you can go to register for the to our events. And secondly, in Hong Kong, we will arrange the Cloud Security Alliance Hong Kong and Macau chapter annual event by in October time. So when we have more details, we'll share with you. So welcome to join our events, and we definitely will have more of the benefits to our members as well. So if one of you not our members yet, feel free to go to visit our website and then to register. And before ending this section, if you have not filled the form from Nora, then go to fill in the form. You will have the chance of lucky draw, and also some of the updates about HashiCorp as well. Okay, so thanks a lot. So see you next month.
Thank you.
Thanks.
Bye bye.
Thank you. Bye bye.